Welcome everybody to the channel, and today in this video I'm gonna talk about implicit differentiation, how we can solve implicit differentiation problems. Actually, if you get to know the way to do implicit differentiation, then you can solve almost any kind of such problems. So we will just go on with a few examples so that you can understand how to do it. Okay, so we are still under derivatives. So in this example, let's say we have this, that's 1, that is x squared y plus x y squared is equals to 6. We need to differentiate this implicitly. Okay, so implicitly means that we have to find the derivative of everything. Okay, so that is going to be d all over dx of x squared y plus x y squared is equal to the derivative d all over dx of 6. Okay, so we're finding the derivative of everything in this function with respect to x. Okay, so the way it's gonna be is like this. First of all, we will differentiate the x squared. Okay, and this mark here shows that we are differentiating the x squared. Then we multiply it with y, and then again we will differentiate. We will keep this x squared, and then we will differentiate y. Okay, we'll differentiate y. Okay, I hope you can see, because eventually it's just like a product rule, because you are going to differentiate if we have x squared y here, okay, and you want to differentiate them, both of them, so we are going to use the product function where we first differentiate the first one, xy, and then we multiply with the second one, then we add we use the plus sign, and then what we do is keep the first one, multiply by the derivative of the second one. It's just the same thing that I showed you in the product rule. If you didn't understand, maybe you could go back and watch this video. I'm gonna put the link somewhere here above. Okay, but that is not our discussion today in this video. Okay, so anyway, that is the point. So now we will go to the other part, which is this one now. So we'll differentiate x and then keep y squared, and then plus keep x and then differentiate y squared. Okay, differentiate y squared. So okay, and of course that if we differentiate 6 with respect to x, is going to give us 0 because it's a constant. Now let's now find the answers of those derivatives. The derivative of x squared is going to be 2x, and then we multiply it with y, then we add this x squared here is just keeping it, so take it again. The derivative of y with respect to x is just going to be y prime, right? Because if you differentiate d all of dx of y, is just going to be y prime. It's just going to be y prime. Okay, this is going to be y prime. So now go on and add. So the derivative of x here is just going to be 1, so we will just take y squared, and then plus here just we keep an x, so write it. The derivative of y squared we are we are going to use the outside inside rule. So first we have to differentiate the outside function, which is by bringing the 2 down, so it's going to be 2y, and then we will differentiate the inside, which is y, so it's going to be y prime. Okay, that's all give us 0. Okay, I hope you can understand how we could differentiate here, how we could differentiate the y squared. So if I show you here, let me just show you. Okay, so if we have d all over dx of y squared, so first of all what we are going to do is we are going to differentiate the outside function by bringing the 2 down, so it's going to be 2y raised to power 1. We just subtracted 1 from the above power, and then we are going to multiply that with the derivative of y itself, the inside function, that's going to be y prime. Okay, so we would end up with something like what we have here, and that all equal to 0. So we are going to factor out the y prime. So the y prime here, we factor it out, it's going to be y prime. So it's going to be x squared plus 2xy. Now, whatever that doesn't have y prime, we will take it to the other side. It's going to be negative 2xy minus y squared. And eventually we are going to divide everything by this. We are going to divide this everywhere. So it's going to be x squared plus 2xy. Here also divide x squared plus 2xy. So eventually what we do have is, let me just subtract this, it's going to give us all of them 1. So eventually what we're going to have is here the derivative of y, would be this. Actually, that's the best way to find the derivative of such a function. The only way we could find the derivative for this function is to do it implicitly. Okay, that is how to do it. So in the next video, I'm going to give you another example of how you can differentiate a function implicitly. Okay, it's just the way we did it here, similar.